Hi guys, welcome back to the daily LeetCode problem series. So let's start today's video. So today's problem is possible bipartition. We want to split a group of n people labeled from 1 to n into two groups of any size. Each person may dislike some other people and they should not go into the same group. So we have given an integer n and the array dislikes, where dislikes of I denotes AI and BI, which indicates that the person labeled AI does not like the person labeled BI, and we have to tell if it is possible to split everyone into two groups in this way. Okay. So we have given some persons numbered from 1 to n, and we have to divide them into two groups such that no two persons which dislikes each other are in the same group. Okay. So I think that this problem can be visualized as a graph, right? So for every person, it will be connected to all the persons which he does not like, and we have to like color the graph in such a way such that no two connected nodes are of the same color. So for example, uh, here we can visualize it like one is a node and it is connected to 2, and 2 is connected to 4, and 1 is also connected to 3. Okay. So now we have to color this graph or divide it into, let's say, two teams, team number 1 and team number 2. So let's say we give 1 in team number 1. Okay, then if it is connected to 2 and 3, then 2 and 3 cannot be team number 1, they should be team number 2. Similarly, we will then mark team number the second person in team number 2, and then we will check from whom he is connected to. So the person 2 is connected to 4, so 4 cannot be team number 2, it should be team number 1, right? So if we encounter any node such that their team number is same, then we will return false. So let's code it. Um, let's first create our graph. Okay, and we have n nodes. Let's fill the graph. Traverse the dislikes array, which is basically edges of the graph, and let's just copy this. Okay, so now we have created our graph. So what we can do is we can do a breadth first search, right? Yeah, yeah, we will do a breadth first search, and as components can be disconnected, so we have to first we have to run it inside a loop. Okay. So let's first create a vector which will store the team number of all the groups. So this will store team number of all the persons, and it will be of size, and initially we will mark them all as 0, and it could have three values, either 0, 1 or 2. 0 means that it has not been visited yet, or it is not part of a team yet. 1 means it is part of team number 1. 2 means it is a part of team number 2. Okay. So now let's traverse through all the elements. Now, uh, if the uh, if the person has already assigned a team, then we do not need to apply BFS for that person. So if team of I is not equals to 0, then we will continue. Now, if the person has not been uh, assigned a team yet, then let's assign the person team number 1. We can assign 2 also, doesn't matter. Let's assign the person team number 1, and let's maintain a variable current, which denotes uh, the current team, right? No, in, let's initialize it with 2. So current denotes the team number, which should be of the connected person to the ith person, right? So, and let's create a queue for BFS, and yeah. So now let's start our BFS. So um, oh, yeah, and we have also we have to push current element into the queue. Now we'll run this loop while queue is not empty, and let's get the size of the queue dot size. So we will go through every element of queue. Uh, so or we should do while s minus minus. So this will run through all the elements of the queue, and we will check if first let's get the top of the element of the queue. So let's call it top is equals to queue dot front, and we will pop the element from the queue. Now we will traverse all the connected elements from this top component. So we have graph. This graph of top will give all the elements which are connected to the current element, and we'll check if the team if it has not assigned a team yet. So if team of I is equals to 0, then we will assign it uh, the team current, and we will push it into the queue. Else, if it has been assigned a team, but the team number which he has been assigned does not matches the current team, then we will return true, because in that case there is no solution to the problem. So we will return false. Yeah. Now last, we will update our uh, current element. So current, we will update it if uh, current is equals to 1, then we will make it 2, otherwise we will make it 1. Yeah, we are updating our current element. And yeah, so if this whole loop runs and we have not returned false, then we will return. So let's run it. Okay, we have done something wrong. Your graph is right. Oh, so they are labeled from 1 to n. So we have to increase our size from n plus 1, and we will start traversing from 1 and up to n. If team 5, oh, we have to increase the size of team also. So it is running correctly. Let's submit it. Yeah, it's faster than 82%. So that's it, guys. I hope you liked the video. I'll see you in the next one.